real zeros of polynomials. So here we have just a kind of generic way to express this, a general polynomial this way. If it has integer, here's a specific example. Okay, here's a specific example. So don't get like too confused by this, and won't worry too much about this. Here's a specific example. In this specific example, n is 3. an, which would be a3, is 14. a2 is 4, so on. And then this a0 is 22, or negative 22. Okay, because that's a plus there. That's negative 22. So that's just a specific example. Now, the rational zero theorem says that if all of these coefficients are rational numbers, or in this case, integers, here integers. So if all these coefficients are integers, in which case they are 4, 14, 4, negative 22, negative 2, those are all integers, then the only numbers that could possibly be rational zeros of P are of the form P over Q, where P is a factor of this last term, and Q is a factor of the first term. Okay, so in this specific case that we're looking at, P is a factor of 22, and Q is a factor of 14. Okay, so a factor of 22 or negative 22, doesn't matter, I guess. They have the same factors. And then Q is a factor of 14. So it's combinations of factors of 22 divided by factors of 14. Okay, so again, this answer is AN, and this is A0. Okay, so it says the possible rational zeros of this are, and then we're supposed to give a list. Ouch. Okay, so this list, so if you look at the factors here, you have plus or minus 1, plus or minus 2, plus or minus 11, and plus or minus 22. And then down here you got plus or minus 1, plus or minus 2, and then 7, and then 14. Okay, so you want to write down all possible combinations of these divided by these. So 1, negative 1. Let's take this 1 and divide it by everything here. 1/2, negative 1/2, 1/7, negative 1/7, 1/14, and negative 1/14. Ouch. Then all the factors are 2, this plus or minus 2 divided by everything here. 2, negative 2. 2 over 2 is going to be a duplicate because we already have 1 and negative 1. And then 2 over 7 and negative 2 over 7 is another one. 2 over 14, that's 1 over 7, which is already there. Okay, 11 over 1 and negative 11. Okay, 11 over 2 and negative 11 over 2. 11 over 7 and negative 11 over 7. And then 11 over 14 and negative 11 over 14. Okay. Now we got 22 over 1 and negative 22. And we have 22 over 2, which is going to be 11, so that's already there. That's already here. 22 over 7 and negative 22 over 7. And we have 22 over 14, which is going to be 11 over 7, which is already there. Okay, so these are the answers to this last part here. All those. That's kind of tedious. And good luck when you put that in. And not missing anyone and not duplicating anything. Okay, number 2, true or false? If C is a zero of a polynomial P, then all other zeros are of the form this one. This is true. Okay, what that means is, let's say that P of X factors into Q of X times X minus C. okay? If you're able to write this in completely factored form, then you can pick off all the zeros from that. So what it's essentially saying, this part right here is your q of x. If you bring this over here to the bottom, you divide both sides by this, you get p of x over x minus c is equal to this q of x, and then all the remaining zeros are going to be zeros of q of x, are going to precisely be the zeros of qx. Okay, number 3, moving along. List all possible rational zeros of this one. Okay, so here we got factors of here are plus or minus 1, 2, 3, and 6. And then this is, oh, great, this is just 1. So that means that these are all the answers. So 1, but you have to write them all out. You can't write this plus or minus stuff. 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. Okay, number 4. List all possible rational zeros of this one. Okay, so here we have, let's do a different color. Here we've got 1, 2, 4, and 8. Those are the factors of 8. And then here we have 1, 2, 3, 4, 6, and 12. Oh dear. So that has a lot of factors. Okay, so it's all these ones divided by those, all combinations of these divided by those. So if we go through, we take the 1 first. And that's 1, negative 1, dividing by 1 down. 1 divided by 2 is 1/2, and negative 1/2. 1 divided by 3 is 1/3, negative 1/3. 1 divided by 4 is 1/4, negative 1/4. 1 divided by 6, negative 1/6. 1 divided by 12. Dang, this is a long problem. Did I really need to do this thing? Oh well. We're almost done, actually. We're about halfway done, actually. So 2 divided by 1, that's 2, and then negative 2. 2 divided by 2 gives us something I already have, so no need to write that again. 2/3. 2/4, that's 1/2, which is already here. 2 divided by 6 is 1/3, which is already there. 2 divided by 12 is 1/6, which is already there. Okay, so that's 2. Now we got 1 and 2. Now it's 4. Okay, and so that's going to give us 4 and negative 4 when we divide it by 1. 4 divided by 2 is going to be 2, which we already have. And then 4 divided by 3 is new. Okay, 4 divided by 4 is 1, which we already have. 4 divided by 6 is 2/3. 4 divided by 12 is 1/3, which we already have all those. Okay, so that's done. So we're done with 4. Now 8, we have 8 divided by 1, that's 8, and negative 8. 8 divided by 2, we already have, because that's 4. And then 8 divided by 3 is 8/3. 8 divided by 4, and 6 and 8, we already have all those. So, whoa, that's a lot of answers.
So just to clarify and be sure, those are coming from the first coefficient and the last number, correct?
Right.
Okay, thank you.
So the last coefficient, the last number divided by the first number, or rather factors of the last one divided by factors of the first one.
Okay, got it.
Okay, great. Those are possible rational zeros. And then we'll get into like, according to the rational zero theorem, okay? That's according to that. And we'll get into some better ways to do this kind of thing. Okay, here's another problem. And here we have this polynomial here. And we're supposed to list all possible rational zeros by the rational zeros theorem. And so again, factors of this one, 1, 2, and 4. And then this right here is 1 and 2. Now, the way that I like to do it is I put plus or minuses here, but I don't over here. Technically, I should, but technically it is, plus or minuses, but it doesn't really matter because they're just going to be duplicates. Okay. So this divided by 1, so that's 1 and negative 1. And then this divided by 2, so that's 1/2 and negative 1/2. And then 2 divided by 1, so that's going to be 2 and negative 2. And 2 divided by 2, that's 1, which you already have. And then 4 divided by 1, which is 4, and negative 4. And then 4 divided by 2 is 2 and negative 2, which we already have. So no need to write any more of those. Okay, so those are according to the rational zero theorem. These are the possible rational zeros. Now, possible doesn't mean that it is. For B, it says from the graph, determine which of them actually turn out to be zeros. Okay, so there's a 0 here, here, and here. When the function just passes through like that, and it looks like if you zero in on, if you take this circle that I have here and you zoom in on that, it's going to look like a line. That means that 0 is multiplicity 1, okay, and negative 1. Here, it looks like a parabola if I were to zoom in. That means that is a double 0. It's multiplicity 2. And so when it says including repetitions, that means we put that one twice. This one looks like a line, so it's just going through, so it's 2. Okay, and in the end, you should have as many zeros as this power here, which is 4. Okay, great. Any questions on that? Okay, so these are the actual zeros. Okay, so we're supposed to find all zeros of this and write it in a factored form. So let me explain how you can go about doing this one. So first of all, you look for all factors here, which would be plus or minus 1, plus or minus 2. 3 is a factor, 5 is a factor, 10 is a factor, and 15 is a factor, and then 30 is a factor. And then this is just 1. So these right here are all the possible rational zeros. Okay, so what you want to do is try to find one of these. Okay, so I'm going to use synthetic division. So I'm going to write down, this corresponds to the x cubed term. There's no x squared term, so I'm going to put a 0 there. This is the x term, so negative 19, and then this is the constant, negative 30. Okay, now the objective is I'm going to choose these numbers here, and if it's a 0, then there'll be a 0 right here. Okay, so if I choose 1, for example, then I've got this 1 coming down, multiply, add, multiply, and that's what, negative 18. Multiply, and that's negative 18. And there's no way that's going to be 0. Okay. And I could have figured that that's not going to work from even before putting this in, by the way. Because another thing is that if you actually plug a 1 into here, it's got to be 0. And there's no way. You got 1 minus 19 minus 30. That's no way that's going to be 0. If you put a negative 1 in, that's not going to be 0 either. If you put a 2 in, maybe. No, wait, 2. No, if you put a 2 in, you're not going to get 0 because you got 8 minus something that's minus some number minus something else. So that's going to be negative. So I put a 2 in. So maybe -2 might work. So I'm going to try -2. And try not to be sloppy about it. So I'll bring that down to -2. Add, that's -2. Multiply, that's 4. 19, that's -15. If I multiply those two, that's +30. And so, yay, I got a 0. Yay. I can even draw a little smiley face here. And make the 0 into a smiley face because we're happy to get zeros here. That means that -2 is a 0. So zeros. -2 is a 0. Okay, now, at this point, I notice down here, this represents a quadratic. And so I can continue putting these zeros in, but it's going to be much easier if I just write this back out as write this back as an equation. And the remaining zeros will be the zeros of this. And here, this is going to factor into what, 5 and 3? So -5 and +3. And then if I set that equal to 0, I get 5 and -3 as my remaining zeros. So that's all the zeros right there. -2, 5, and 3. And then the factored form is going to be x plus 2. That's from the -2, 0. And then these two. Okay, so the polynomial here is equal to this. Okay, number 7, we have the same sort of thing going on with number 7. Find all zeros of this. And let's see, we have plus or minus 1, 2, 4, and 8. Let's see, is 1 going to work? Let's say if I change all these x's to 1, I get 1 plus 6, that's 7. Plus 7 is 14 minus, oh, this is minus 14, those two to combine me on. So 1 is actually going to work. Let's go ahead and try that. So putting these coefficients down here, 7 is next, then -6, then -8. If I bring the 1 down, multiply, add, that's 7. Multiply, that's 7. Add those, that's 14. Multiplying that, you get 14. Adding, you get an 8. 1 times 8 is 8, and that's 0. Okay, so 1 is a 0. This one here. Okay, now, at this point, what you want to do, a couple of things. The main thing is that after you find something's a 0, then you use this now. You don't use this anymore. Okay, you use this one right here. This is a cubic, 3rd degree. Like this was 3rd degree. So we still need to do this. In this particular case, I can even use this. In this particular case, no positive number is going to work here. Okay, so at this point, no positive number is going to work. You sort of see that? The reason is that if you have a positive number here, then you pull this one down, you multiply by that positive number, that's positive. Yeah, those, that's going to be positive. Put it there, that'll be positive. Add those, that's positive. This will be positive. And 8 plus a positive number is not, there's no way that that's going to be 0. There's no way that's going to be 0 if you have a positive number here. So that's not going to be a 0. So we can ignore all the positive numbers. Let's try -1. So bring on the 1, multiply, that's -1. Adding those, you get 6. Multiplying, you get -6. 14 minus 6 is 8. Wow. Multiplying, you get -8. Oh, great, that works. That adds up to 0. So that's great. So -1 is a 0. And then what you want to do is you want to rewrite this as a quadratic, and then try to factor it. And it looks like 4 and 2, which means that -4 and -2 are zeros. So -4 from here, -2 from there. Okay, so there's your zeros, and then factored. Well, you have these two right here. And then from the 1, you're going to have an x minus 1. And from -1, you're going to have an x plus 1. Okay, and so that'll be the factored form. Okay, let's move on. Find all rational zeros of this and write in factored form. Okay, so you're looking at factors of this one, plus or minus 1 and plus or minus 5. Only 2 of them, yay, but before you celebrate, look at the 15. It's got 1, 3, 5, and 15. Boo. Okay. So okay, let's start trying numbers. We can try 1. Bring the 15 down, multiply, that's 15. Adding those is, dang, 60, no, -62. Multiplying, that's -62. Okay, there's no way that's going to be 0. So we will back it up and try -1. Okay, that's going to be a huge negative number. So there's no way that's going to be, there's no way that's going to work. So I'm going to back that up. And we'll try 5. Okay, so 5 times 15, whoa, 75? Oh, now we're talking. Now that's only -2. 5 times -2 is -10. -10 plus 9 is -1. And 5 times -1 is -5. Yay. That's good news. Okay, so now five is a 0, so we'll go ahead and put that there. And we need it's cubed, so we need 3. We need 2 more. Although you might have a situation where there are polynomials that don't have rational zeros, that have irrational zeros. Okay, and then so the irrational zeros don't follow the same rules. You can have zeros that aren't in this list that I'm talking about, by the way. And that's where it gets kind of annoying. Okay, but we'll get to that in a little bit. Okay, so now we have a quadratic right there. So that means that we go ahead and write that down, and we shift into the other gear. Okay, so here we're gonna, it looks like this is gonna be factoring. And I'm just gonna try 5x and 3x. Let's see, is that gonna work? Well, these have to be ones. Maybe make that a negative, because that makes the negative 5x, and then that's positive, so that's plus 3x. So that works. So if this one of this is a 15x squared. 5x times negative 1 is negative 5x, and then inside is positive 3x, which adds up to negative 2x. And then the last one is 1 times negative 1, which is negative 1. So this works. Okay, so this is this factors into that, and this is going to give us negative 1/5, and this is going to give us 1/3. Okay, so negative 1/5 and 1/3. And that means that it's going to factor into x minus 5 is from here, and then these two terms, like that. So you get that. Okay, great. So now, number 9. I'm going to show you an easier way to do this, okay? So we're going to go to Geogebra. Geogebra. This can really help you a lot, okay? So we got 3x to the 4th minus 5x cubed minus 18x squared plus 11x plus 20. I'm going to go to Geogebra. I'm going to put this function in there. Okay, so here's my Geogebra. Start the calculator. So geogebra.org, go to the calculator. Go right there, and I'm going to put in 3x to the 4th minus 5x to the 3rd minus 18x squared plus 11x plus 21. Okay, now the zeros are going to be where it crosses the x-axis. And if you just click on, you can zoom out if you want, or zoom in, or whatever, you know the drill. So if you click on these, okay, this is some weird number. This is negative 1. Okay, so remember that. So negative 1. This is some number with a lot of decimal places. This is 3. Okay, so negative 1 and 3. So just remember those two numbers, negative 1 and 3. Those appear to be zeros from the graph. Okay, don't worry about the other two for now. And in fact, if you put these answers in, it's going to get marked wrong. If you put negative 1.7, blah, blah, blah. Or if you put this one, it's just going to get marked wrong. Okay, but negative 1 and 3, they look like for sure they're those are zeros. Okay, so remember those two. We'll go back to the paper, and the two numbers were negative 1 and 3. And so what you're going to do is you're going to do synthetic division with those two numbers that we just got. Okay, so 3, negative 5, negative 18, 11, 21. So I'm just putting these in. And when I do synthetic division with these, I should get a 0 right here because the graph said those were zeros. So I'm going to predict that that will be successful already. Okay, so -1 times 3, that's -3. Adding those together, you get -8. Multiplying, you get +8, and this is 7. No, -7. Okay, -1 times -7 is +7. Wait a minute, I go wrong somewhere. No, this is -18. What am I doing? That's the advantage. You know this is going to be 0, so you have to. So if it's not turning out to be 0, then there's something that you did wrong. Okay, so -18 plus 8 is -10, and -1 times -10, that's +10, and that's 21. Multiplying those together, you get -21, and that adds up to 0. Yay! Then, okay, so let me keep track of the zeros here. We determined that -1 was a 0. We also determined that 3 was a 0 from the graph, so put 3 there. And do 3. Okay, then bring the 3 down, multiply, that's 9. Adding those, you get 1. 3 times 1 is 3. -10 plus 3, it's -7. 3 times -7 is -21. Okay, and that adds up to 0. So that's good too. Okay. So far we have -1 and 3 as zeros. Okay, now you've got this quadratic here. So we go to the next stage, which is we pull that off as 3x squared plus x minus 7. Okay, now we know from the GeoGebra that these are weird numbers. They're not going to be, they didn't appear to be rational numbers. So that means that we're probably not going to have any luck trying to factor this. And in fact, no, this is not going to factor very easily. So we're going to use the quadratic formula. -b. So a, so let's keep in track here. A is 3, b is 1, and c is -7. Okay, so -b, which would be -1, plus or minus the square root of b squared, which will be 1, minus 4 times a, which is 3, times c, which is -7. All over 2a, which is 2 times 3. Okay, so -1 plus or minus, let's see if we can resolve this. So we have 12, okay, so 4 times 3 is 12, and then times 7 is 84. It's actually 1 plus 84, so it's the square root of 85 all over 6. Woohoo. Okay, so those are our other two zeros. So we have -1 plus the square root of 85 all over 6. And then we have -1 minus the square root of 85 all over 6. Okay, now by the way, these two zeros are irrational. Okay, so in the list of possible rational zeros, these would never come up in any of those lists. Yet they are zeros of the function. Okay, let's move on to the next exercise, number 10. And here we're supposed to find all real zeros of this polynomial. Okay, it's to the 4th power. So again, we're going to go to GeoGebra. So let's go ahead and let's go on over to that. So what's this? We're going to put in -x to the, when we go to GeoGebra, we'll put in -x to the 4th plus 10x squared plus 8x minus 8. Okay, someone already put a function in here. How did that come from? That's okay. We'll just delete what the people put in here. And it was what? Negative x to the fourth plus 10x squared plus 8x minus 8. Hit enter. Okay, great. So let's go ahead and look here. So looking at the zeros, that looks kind of weird. This looks even more weird. This looks really weird too. But this is the least weird of all of them. It's a negative 2.0. It's got 6 zeros there. When you have something like that, there's a really good chance that this is just a round-off error. So -2 looks like a 0. And because it's, see how it's coming up and just touching the graph right there? And then going back, it looks like a parabola right around there. Because of that, then it appears that -2 is a double 0. Okay, so let's remember -2. We'll go back to the other document. These two right here appear to be irrational zeros again. So, but we'll just look at this one right here, -2. That's all we need. We can figure the rest of, we'll figure out the other ones later. Okay, so it looked like -2 was a double 0 from the GeoGebra. Okay, so we just use synthetic division with -2. Like that. So bring on the -1, multiply, that's 2. Add, that's 12. Multiply, that's -24. Adding gives you negative. Something's wrong. Anybody see where I went wrong? Dang, I'm really confused. Oh. Well. Okay, so here, okay, I see what the mistake. Okay, so I went from x to the fourth x squared. So I missed all of the, I should have a 0 here instead of a 10. I'm so sorry about that. Okay. But I guess I'm showing you what happens when you don't put a 0 in there. So there should be a 0 there and then a 10 next. and then an 8, and then a negative 8. Okay, and I should get a 0 here. I'm confident. I'm gonna, well, maybe I shouldn't put a smiley face yet because I'm kind of celebrating prematurely. I think I'm gonna get it this time. So 2, bring the 2, add those, that's 2, multiply, that's negative 4. Adding here, I get a 6. Multiplying here, I get negative 12, which adding here, I get a negative 4. Multiplying here, I get a positive 8. So those do add up to 0. Okay, so, but 2 was a double 0, so I'm going to do it again. But I'm going to do it with this one, with the results. Okay, so once you find the zeros and you got this, then you only work with the next line from then on. You never go back to working with that one, okay? Because that's just going to be more work. And especially here, you've got negative 2 as another 0. So you really, it doesn't work to go back to that one there. Okay, multiplying there, you get 2. Adding is 4. Negative 2 times 4 is negative 8. Adding here, you get negative 2. Negative 2 times 2 is, negative 2 is positive 4, which adds up to 0 again. Okay, and then from here, you're going to reconvert it back into a polynomial when we have it down to a quadratic. Let me go ahead and factor a negative out because that's not really going to matter. So x squared minus 4x plus 2. And that's not going to factor. But I just use the quadratic formula. So a is 1 from here, b is negative 4, and c is 2. Okay, so we have negative b, which is positive 4, plus or minus the square root of b squared, which is going to be 16, minus 4 times 1 times 2. 4 times a times c, all over 2a, which is 2 times 1. Okay, so that's 4 plus or minus the square root of, this is 16 minus 8, that's going to be 8, all over 2. 8 is the same as 2 times the square root of 2. And we can factor a 2 out of the numerator, and that leaves us with 2 plus or minus the square root of 2, all over 2, and then these 2's reduce. So we have 2 plus or minus the square root of 2. Okay, so in writing down all the zeros, we have, first of all, we have these 2 negative 2's, and then we have these. So 2 plus the square root of 2, and then 2 minus the square root of 2. Those are all the zeros. And this one right here is what, this is, since we graphed it in Geogebra, we kind of know that this is what it looks like. Right here. So that's the answer to that part. Okay, let's see, what else do we have? Number 11. Okay, so this is the last one. And so again, here, we'll go ahead and, well, with this one, I guess what we can do is the x, this last term is an x, right? It's 5x. So that means that we can go ahead and factor an x out of everything. To get that. So we factored an x out. So now what we're going to do is we're going to take this piece and we're going to run that through GeoGebra. Okay, so 8x cubed minus 6x squared minus 9x plus 5. So 8x to the third minus 6x squared minus 9x plus 5. Hit enter, and it gives me a new graph. Okay, it looks like -1, and then, oh wow, 0.5 and 1.25. So this looks like 1/2, and that looks like, what, 5/4? But let's just take this -1 and go and run with that one. So we know that -1 is 0. Okay, so we're going to use this one, by the way. So 8, -6, -9, and 5. Okay, so bring the 8 down. Multiply, that's -8. Adding, that gives you -14. Multiplying, that's going to be +14. Adding those together gives you +5. -1 times 5 is -5. Adding those gives you 0. So that's the other one. Okay, so let me start listing the zeros. Okay, so first of all, the fact that we're able to pull this x out means that that's a 0. And then we also have a -1. And then if you remember from GeoGebra, it was 1/2 and 5/4. But so I guess we could have just got them all from GeoGebra. But let's just double check right here. So if we convert this to a quadratic, then when we go to factor it, let's see, 4x and 2x, let's try that. Maybe a 5 and a 1, minus and minus. That does it. So this 4x times that is negative 4x, and then the inside gives you -10x, which adds up to -14x. And then from here, you have x is 5/4, and from here, you have x is 1/2.